This video will show the standard calibration routine recommended by Brookfield Engineering. A periodic calibration check is essential to ensure your viscometer is working properly. You will need a silicone or mineral oil viscosity standard fluid, a water bath, and a 600 milliliter beaker. There are other instruments, such as a cone plate configuration, that require a different method for calibration. Those will be dealt with in subsequent videos. Select a viscosity standard fluid based on the torque range of your instrument. For example, an LV torque instrument has a minimum viscosity range of 15 centipoise, so a 500 CPS fluid will be fine. For this calibration example, we will use an LVDV2 Plus Pro viscometer and a 500 centipoise viscosity standard fluid. You do not need to select a standard fluid based on the viscosity value of your material. However, many customers choose to do so as a simple verification. The calibration routine checks the linearity of the spring on the instrument by using one fluid at 3 separate speeds to achieve low, medium, and high torque ranges. This checks the linearity of the spring and the sensing mechanism of the instrument. Use the actual value of the fluid, not the stated value, for the calibration check. Make sure the instrument is level. The viscosity standard fluid needs to be equilibrated at 25 degrees Celsius to get an accurate reading. Fill the 600 milliliter beaker with the viscosity standard fluid and place this in the water bath. Select the spindle you will be using to run the calibration check. Remember, with an LV or RV number 1 or number 2 spindle, you will need to use the guard leg to get accurate readings. For proper temperature equilibration, the fluid, spindle, and guard leg, if appropriate, all need to be equilibrated at 25 degrees Celsius. The viscosity standards are very sensitive to temperature. The temperature probe on the Brookfield viscometer is accurate to plus or minus 1 degree centigrade. To ensure proper temperature equilibration and accuracy for the viscosity standard, use a calibrated thermometer with higher accuracy. The temperature of the viscosity standard should be controlled at 25.0 degrees centigrade, plus or minus 0.2 degrees centigrade. The thicker the fluid, the longer it will take to equilibrate. For this 500 centipoise fluid, approximately 1 hour should suffice. Based on the spindle you will be using, select 3 speeds that will give you a low, medium, and high torque value. The minimum torque value for a good reading is 10%. A low torque range would be 10 to 30%, a medium range 30 to 70%, and a high torque range above 70%. This will check the linearity of the spring on this instrument through its full range. With the digital instrument, you can easily find the full-scale range by turning on the motor and pressing and holding the auto range button. For example, if you have a 100 centipoise fluid, a full-scale range of 200 centipoise will give you 50% torque. Tolerances for calibration are computed using plus or minus 1% of the actual fluid value and plus or minus 1% for each full-scale range. Added together, this then gives you the tolerance for your reading. You can perform a calibration check manually and enter the values and compute the tolerances for pass-fail criteria. Brookfield supplies a calibration worksheet on our website that easily allows you to enter data, computes the tolerances for each range, and gives pass-fail criteria automatically. You can download the calibration worksheet from Brookfield's website at www.brookfieldengineering.com. Going to the link on your screen will take you directly to the calibration worksheet. To see what these tolerances mean, let's look at this calibration worksheet. Enter data in the bold fields. First, enter the spring torque of your instrument. In this case, this will be an LV. Enter the actual value of the fluid in column A. The remaining fields in this column will automatically update, as this value will not change. You can see the 1% fluid value column will update based on this entry. This is the accuracy of the fluid. Enter the spindle code in column D. Again, the fields in this column will automatically update. Enter the 3 speeds you will be running in column E and observe the 1% full-scale range in column G is updated. This is the accuracy of the viscometer at this range. Now, run the 3 speeds you have selected. Record and enter the data in column I. Your results will show up in the box below. The low limit tolerance is column A, the actual fluid value, minus column B plus G, which is the 1% value of the fluid, plus the 1% value of the full-scale range. This high limit tolerance is merely column A, the actual fluid value, plus column B plus G, which is the 1% value of the fluid, plus the 1% value of the full-scale range. Simply put, the actual fluid value is 484 centipoise, and 1% of this value is 4.84 centipoise. At a speed of 12 RPM, the full-scale range is 2500 centipoise, and 1% of this value is 25 centipoise. Thus, the tolerance on the fluid at this speed with this LV2 spindle would be 484 plus or minus 29.84 centipoise. You can see a graph of your results with this worksheet and the tolerances. Select the Calibration Graph tab to view the results. The data points are plotted and upper and lower tolerances shown. In this example, you can see the data points came within tolerance. And that's it. You have performed a calibration check. Remember the important aspects of performing a calibration check: temperature, actual fluid value, torque ranges, and full-scale range. If you find the instrument is not within tolerance after performing a calibration check, repeat the calibration test to ensure everything was done correctly. If your instrument is still not within tolerance, contact Brookfield Engineering or an authorized dealer. A common question is, how often should a calibration check be run? The answer is really up to how often the instrument is used. For example, if an instrument is being heavily used, say on multiple shifts, a daily calibration would ensure accuracy. Daily usage, 5 days a week, may require a calibration check be performed at least once a week. For instruments used less frequently, perhaps once a month or once every few months will be fine. But to ensure the health of your instrument for many years, return this to Brookfield or an authorized dealer once a year for a full calibration, certification, and cleaning. Thank you for taking the time to watch this Brookfield video. Please check the Brookfield website for new videos that may be of interest. If you have suggestions for future videos that could be of help, please email your input to sales@brookfieldengineering.com.